of the industry. So these are some of the use cases. The most common use case of Kafka is to do this real-time data integration. So what's the problem? The problem is in a lot of companies, you have data stored in a lot of different places. This can be data stored in your databases, in some of the traditional database or some NoSQL database. It can also be data in your log files. It can also be data in your syslog or maybe operational metrics through GMX. So these are all those data sources at the top. At the bottom, you often have various systems that are data destinations that want to be able to tap into one or more of those data sources. For example, those data probably want to go feed that into your Hadoop system, into your data warehouses, into your search index, into your recommendation system, into your graph processing engine, right? So one of the challenge in this picture, if you want to do data integration, is how to avoid this unsquared problem where you have to manage all the different data sources and potential n different data destinations. Of course, building this unsquared individual data pipeline is going to be unmanageable. So this is where Kafka can come in. So if you have Kafka that's in the middle, what you can do is to have all those data sources just publish data into Kafka, into one or more of those topics, and the data will be available there for all kinds of consumption. So all those data destinations you have can just make a subscription to Kafka based on the data that you want, and you turn this unsquared problem into a linear problem. This is actually much more manageable, of course, because Kafka is designed for handling this high volume of data. This fits this architecture perfectly because we can handle all types of data at volume. This is not necessarily the only use case people want to have. There are a bunch of other things people are sort of adopting Kafka for. For example, some places, even if you don't necessarily have high volume data, you can adopt Kafka for scaling your database. Maybe you have your data stored in MySQL, and the MySQL works for your data volume. But over time, what's going to happen is typically we have more and more applications. They want to read the data you stored in your database. And they want to read this in a streaming fashion because they want to keep up all the changes. And a lot of databases, they are not super optimized for delivering the data in a streaming fashion. So if you want for some data, you have to keep pooling the database. Then over time, if you have lots of those consumers, then the database load could be more than what the database can handle. So a much more effective mechanism is to just read the data out of the database once and publish that into Kafka. And from there, you can tap into the system with any number of subscribers. And Kafka is super optimized for delivering data in a streaming fashion. So we can handle a lot of more applications reading the data than the databases. So that's another common use case. There are also other uses for just messaging. This is actually especially getting more and more popularized with those microservices, because now you have different independent services. You want to have a mechanism to reliably communicate among those services for asynchronous processing or for event handling. Last but not least is for stream processing. So once you have all the data collected in real time in Kafka, the next thing you probably want to do is to do some computation on that. For example, a lot of the ETL process that used to be done in batches in Hadoop, now over time, if those data are available in real time, you probably want to do that in real time. So one of the ways you can do this kind of processing is to use one of the streaming libraries or engines to just tap into Kafka and apply all the transformation logic on the data. So that's another sort of common use case. So these are sort of the patterns that we've seen people using Kafka. As you can see, in a lot of cases, Kafka are used for some pretty mission-critical use cases. So it's really good to be able to set up in a reliable way. So that's what this talk will be mostly about. So the main talk would be on handling multiple data center with Kafka. So just to get us started, why do we want to care about multiple data centers? These are typically for two main reasons. The first one is for disaster recovery, especially if you have mission-critical data, right? If you lose your data center completely, you want to have a mechanism to be able to recover from another one, so be able to replicate your data across those data centers would be useful. The second use case is on geolocation. So you may have data produced, for example, in one data center, but you may have another application that's sitting in another data center that want to tap into the same data. Of course, a simple way is to allow that application to just read the data remotely, right? But there are two downsides. The first one is on network bandwidth, because typically across data center, the network bandwidth is limited. If you have to repeatedly reconsume the data remotely, they will be competing on the limited bandwidth. The second reason is on security. In some of the places for security reason, you may not want to give every application the permission to read data remotely. So in both cases, it's a lot better to be able to replicate the data from one data center once to another, so that after that, all the access to the data can be local. So then you get a benefit of higher bandwidth, you get a benefit of easier manageable security. So these are the two common reasons for having multiple data centers. Of course, these are pretty common in pretty much every other system that you want to set up for multi-data center. So what's a little bit unique with Kafka compared with other data storage systems like a database? So one of the things you will see later on, one thing that's a little bit unique with Kafka is the clients, especially the consumer, has states. So if you are familiar with Kafka, the way the consumer works is you make a subscription, and the consumer can live forever. You just continuously getting new data in a streaming fashion from the brokers. So as the consumer is making progress, we have to keep track some states where this consumer is up to. So this is represented in offsets, if you're familiar with Kafka. So one of the challenges you will see is when you switch from one data center to another, one of the hardest things is what do you do with the consumer states? A lot of other data stores, they don't have this problem. You know, you issue a query, and that query is like transient. If you flip it, you have to start a new query. But in Kafka, because this is a continuous client, so you sort of have to reason about how do you maintain the states when you switch data centers. So that's one of the challenges we'll be talking about. Okay, so in the next few slides, what I'm going to do is I'll just walk with you guys with some of the common patterns we have seen when people are deploying Kafka in multiple data centers. The number one pattern, this is what we call stretch cluster. This is actually commonly used in AWS, especially when you just set up a Kafka cluster within a single Amazon region. The way this set up is you will use 3 availability zones in the same region, and your data center is really an availability zone. Okay? So you will deploy all the Kafka brokers and zookeepers across all the 3 availability zones, but in the same region. So it forms a single cluster. In Kafka, we already have support for intra-cluster replication, which means if you create a topic with enough replication factors, in this case, you probably want to have at least 2 or 3, then every time you publish message, we make sure those data will be replicated in a strongly consistent way across multiple replicas. And since we only expose those sort of committed data to the consumer, and we guarantee that every time the consumer flip over to another replica, is guaranteed to see all the messages it previously has seen. Okay. So this is already done through our intra-cluster replication. So in this case, if you happen to have all the brokers spread across all those different data centers, our intra-cluster replication makes sure the data can be replicated across data centers, all those different availability zones for you automatically. Okay, so once you just set this up, now let's say one of the availability zone fails. Now how do you do the switchover? It's pretty easy because in this case, you are still living in the single Kafka cluster world, right? And if the data center fails, flipping the producer is easy. You just need to move it to one of the other availability zones that's available. Flipping over the consumer is also easy because from that perspective, it's as if you lost a single individual broker. So when you switch over, all the data is still there through our internal replication. And the offsets, if you are familiar with that, by default now are also stored within Kafka in a special topic. So the offsets data will also be replicated seamlessly using our intra-cluster replication. So when you resume, you can pick up exactly the last committed offset for those consumers. Okay. So there's pretty much no work you need to do in the application, which is pretty easy. Now, what happens when a data center comes back? The same thing happens because the built-in replication we have, if your data center starts up, or the intra-cluster replication logic knows how to automatically re-replicate all the missing data for you. And once they are fully caught up, now those restarted data center can now be put into use. You can switch some of the producers and consumer over, and a lot of this will be done automatically for you. So that's also pretty easy. Okay, so with this setup, one of the things you have to be a little bit careful is the replica assignments. So one of the things you don't want to happen is to have all the replicas for a given topic partition to be in the same data center or in the same availability zone. What this means is if you lose an availability zone, you are losing all the replicas, right? You're not getting the protection that you wanted. So this is actually made convenient in our latest release, which is the 0.10 release in Apache. In 0.10, one of the features we added is this rack-aware support. So with this, what you can do is if you set up these brokers across different AZs, you can configure all the brokers in the same AZ with the rack, with the broker rack property. So you will set them with the same property, and different AZs you were given different labels for the rack. Once you do that, now if you are creating a topic, what we'll make sure is we'll make sure the replicas are spread into as many as racks as possible. So you automatically get this redundancy. If you are before 0.10, things are a little bit complicated. So typically what this requires you to do is you have to create a topic manually. And when you create a topic manually, you can specify the exact replica assignment to those brokers. And then you can take into consideration your broker layout in these different availability zones. But if you can upgrade to 0.10, this will be a lot easier. One of the things with this stretched cluster is it's not easily generalizable. So typically, we only recommend you do this within the same region. We're not recommending you do this across regions for a few reasons. The number one reason is for asymmetric network partitioning, which will be more common when you have data centers far away from each other. So in this case, let's say, suppose you set up a single cluster across 3 regions, right? You spread all the brokers and Zookeeper across those servers in different regions. Today, in Kafka, the way we detect broker failures is all done through Zookeeper, which means as long as a broker can register to Zookeeper, we think it's still alive, and we think they can communicate with each other without any issue. Now, in this case, what can happen is, let's say the communication channel between region 1 and 2 is fine, and between region 3 and 2 is also fine. But the communication between region 1 and 3 is disconnected. But in this case, it can happen all the brokers potentially can be registered through the Zookeeper instance that's in region 2, because the network is connected is fine. From our cluster's perspective, all the brokers are successfully registered in Zookeeper. They're all alive. So after that, we can make a decision. We can say, oh, since everything is alive, we'll say, oh, we'll assign some of the leaders to be here and some of the followers to be here. And we expect the replication will happen directly between region 1 and region 3. But in this case, if a network there happens to have an issue, then that will break the replication scheme. So then your cluster will be in a little bit of this weird issue. So this is a lot of that is just the asymmetric between how we detect failure versus the reality of the network. This is less likely to happen within a region, but the probability probably will be higher if you do this across region. This is the number one reason. The second reason is just on the network latency. If those regions are far away from each other, it just means the produce request will take longer, and when the consumer sees those data, it will also see a longer delay because we have to make sure the data is actually propagated to every region. The last thing is on bandwidth, because if this is across regions, right, you definitely need those cross-region bandwidths, which could be limited. Today, from the consumer's perspective, there's no read affinity, which is if you want to read some data from Kafka, you always go to the leader broker, whichever location this leader is at. So which means if this leader happens to be on a remote broker, you have to pay the remote bandwidth. So you don't get the local bandwidth benefit. So these are some of the things that that's affecting this stretch cluster design. So in general, we only recommend you use this within the same region, but not do this across region, which means if you want some cross-region redundancy, you still need some other solutions, which we'll go through in the next few slides. Okay, so another strategy you can do, this is actually meant to be designed across regions, is what we call active-passive. So this is very similar how you would set a database. A lot of people are familiar with how you set up this in MySQL or other databases. You have like a primary and have a passive. This is more or less in the same line. So the way you set this up is now you will set up 2 independent Kafka clusters per data center. In this case, one in data center 1, one in data center 2. And you will designate one of the clusters to be your active one, active in the sense for the producers. So normally you will only enable producer in one data center, right? So in this case, the producer will be on data center 1, you can publish data there. Now, to make sure you get a data in the data center so that you can do the failover, you will be using one of our tools called Mirror Maker to mirror the data from data center 1 into data center 2's cluster. So now the data will be in both data centers. From the consumer's perspective, the consumer can go on either data center. It depends on which one you want to choose, but they will have pretty much the same data. The data in the data center 2 will be a little bit behind from the data center 1, but typically they should be pretty real time. So this is how you set it up. Okay, now just a few words on Mirror Maker. So if you are not familiar with Mirror Maker, it's a tool that basically has an embedded consumer, which reads from the source Kafka cluster, and also embeds a consumer. It embeds a consumer that reads from the source cluster, and it also embeds a producer, which publishes to the target cluster. So that's pretty much what a tool does. There are a few things about this tool. One is, in general, we don't preserve the global ordering, but we do preserve the per key ordering. In Kafka, we have this concept called keys. It's optional, but you can set it per message. If you set messages with keys, when you do the mirroring, what we guarantee is all the messages with the same key as you are mirroring them from the source cluster to the target cluster, all those messages with the same key will be mirrored in the exact same order as the source. But beyond that, there's no strong guarantee. The second thing you want to be aware of is this mirroring is always a little bit asynchronous because it's a standalone tool. It's unlike the intra-class replication, which is always synchronous. In this case, you should expect the target cluster will always be a few messages behind. In general, it's pretty real time, but in some of the cases, you should expect some of the messages will only be in the active data center, but not necessarily propagated to the passive one, depending on how fast the mirroring is. The last thing, which will affect some of the discussion in the next few slides, is when you set this up, in general, the offsets are not preserved between the two clusters. There are a few reasons for why the offsets can't be easily preserved. One is you may not have configured the exact same number of partitions right, across the two data centers on a topic. So of course, offsets is a partition concept. If they don't match, they're not going to be the same. The second thing, which is more subtle, which is on retries on failures. So if you're mirroring the data, right, if you are trying to publish some messages to the target cluster, if you get a transient error, let's say the leader has moved, what would you do? Now, in order not to lose that message, often you have to retry that, which means you have to republish it. When you republish, there is a possibility for you to introduce duplicates because the previous failure doesn't necessarily mean the message is never published. It just means the message may not be published. So there's a probability it can publish. It's just you don't know for that for sure. Now, if you resend it, there's a chance that you will be sending the same thing a second time. Now, once there are duplicates in the log, you can see the offset is going to be very hard to be consistent between the two. So that's sort of the second reason. These are the things you have to be a bit aware with Mirror Maker. Okay, with this setup, now what happens when the primary or the active data center fails? Okay, so if the primary data center fails, the first thing you have to flip over the producer. Flipping that is relatively easy. You just move it over. So now the producer will be publishing on the other Kafka cluster in DC2. The harder thing to do is on flipping the consumers, because one of the things we mentioned earlier is the consumers have states, because they have to keep track of the offsets that they are consumed up to on those topics. And one of the tricky things with this setup is the offsets are not interchangeable between the two clusters, right? So which means when you flip from one data center to another, you can't really just easily use the offset you had before, because they may not map to exactly the same message in the new cluster. Okay, so what do you do in this case? We don't have like perfect solutions right now, but these are some of the possibilities. The first thing you can say, oh, when I flip over to the new cluster, I can just say, oh, I will just consume from the beginning, or consume from the smallest offset there. Now, with this setup, you're guaranteed you won't be missing any data. You will be re-getting everything again. But if you retain the data for a long period of time, then you can get lots of duplicates, which could be an issue. Right? Another option is you can say, oh, I'll resume from the latest message, just the last message. I'll ignore everything that's already there, but I will pick up all the new messages since there. So there, I think depending on how quickly you flip over the consumer, there's a possibility you may miss some messages, because if there's in the window when you flip over, there could be new messages already produced, right, to the second data center. But for a lot of real-time consumers, this may be okay, because you avoided a lot of the duplication compared with the first case, and if you can flip over quickly, there's a little window that you may miss some of the messages. And if you can tolerate that, that may be a workable solution. Okay, if neither works for you, you don't want to lose any messages. You also don't want to get too many duplicates. Another possibility is to do this to do this timestamp to offset translation. So often when you do the flip over, right, you know roughly when the exact time when you stopped consumption on the previous cluster. So when you flip over, you can say, okay, the offset is not interchangeable, but I want to restart consumption based on the message you had 5 minutes ago. If we can translate that timestamp into an offset in a target cluster, then you can more or less resume the consumption from where you left off, right? Even though the offset is not interchangeable. You may still get some duplicates, but it should be a lot smaller. So today, in the released version we do have some API that allow you to do this, but it's not very convenient. There's a lower level API that you can use, but to be able to use that API, you have to do a bunch of other things. The second thing is that API doesn't give you a very precise translation from the timestamp to offset. We're improving this as we speak. In the 010 release, one of the things we added is every message will now have a native timestamp field. You can set it to be either producer time or the server time, depending on your need. What we are adding now is a time-based index on the server. So with this, you can give us a timestamp. We can translate that timestamp into offset using the index we build on the server side. So this will be more precise, and we'll make sure the API is easier to use. With this, once this is out, this will make the switching of the consumer much easier in the future. The last option we can do is we can try to just bite the bullet, try to make sure when we do the mirroring, we'll preserve the offsets. So this is in theory doable, but you do need to add more logic on the server side to make sure if you happen to send a duplicate message during a retry, we can at least recognize that and deal with this accordingly. So we know roughly how we want to do it. It's more work to do. That's why I think we haven't really have a timeline for this yet. Okay, so another thing you have to worry about is, okay, so now I favored over, right? But at some point, the active data center may come back. What do I do now? Now, since you already have some new data starting getting produced in data center 2, right? You have to make sure you get those data back to data center 1. So that's actually one of the more subtle things you have to do in this active passive setup, which is you now have to reverse the mirroring by mirroring data from data center 2's cluster into data center 1. So now you have the same challenge in managing the offset, which is from which offset do I resume the consumption for Mirror Maker? So you can use some of the similar solutions as we mentioned before It's not necessarily convenient, but these are some options you can have. Okay, so with this setup, we sort of understand a little bit of limitation of this active-passive setup. One is there's a little bit of potential manual reconfiguration you have to do, right, when you flip the mirroring. The second thing is, if you look at this, the producer only lives in one data center, right? Consumer, you can still spread it around, but producer only lives in one, which means depending on your consumption production ratio, you may not be able to fully utilize resources in both data centers. This is another potential limitation. Okay, so next one pattern we'll talk about is we're trying to see if we can improve that a little bit. So this is a pattern what we call active-active. Okay, to set this up, one of the changes you have to do is per data center now you have to set up 2 independent Kafka clusters per data center. One is called a local cluster. The other is called aggregation. So the way you set this up is you will be setting up all those mirroring pipeline between the local and aggregate. So you say, oh, this local gate data it will be mirrored over here. It will also be mirrored over here. This local cluster data will be mirrored over here, will be mirrored over here. Now, with this setup, your producer can be active in both data centers. You can produce over here, you can produce here. It doesn't matter. The data in both data centers eventually will land up here as well as here. So in both data centers, the aggregate cluster will have data from both places. If you are a consumer, depending on your need, if you want to just consume the local data, you can actually directly just tap into the local cluster for consumption. That typically means you will be running them together simultaneously. If you want to see all the data, right, in a single consumer application, then you can choose one of the aggregated clusters to consume from. Okay. So one of the reasons, as you can see, why we want to introduce this aggregate cluster is to avoid cycles during mirroring. Today, the mirror maker is not super intelligent. If you set up these cycles during the mirroring, right, it just means the same message will be mirrored over or over again until run up storage. So with this setup, you can see by introducing a second cluster, we are breaking the cycles. In all those pipelines, you can see there's no circles in the mirroring pipeline. So then we won't have this problem. But you do need to set up a second Kafka cluster. Okay, so with this, if one of the data center fails, how do you recover from this? Well, moving the producer is easy. You just need to flip over some of the producer over. The consumers, the same data is there, but you have the same challenge, which is in general the 2 aggregated clusters. Their offsets are not the same because they are populated sort of independently. So then they have to go back to the same things we talk about. How do you set the consumer offsets when you do the flipping? So that problem is still there. But one of the problems this setup solves compared with active-passive is now when this data center comes back, the setting up is easier. There's no reconfiguration you need for reverse mirroring because this is all set up once. And if those services are up again, they just automatically copies all the missing data from the other cluster, and then eventually all the data will be back into this aggregate cluster again. And after that, you can decide to switch some of the consumers or producers over. So it's pretty convenient. So this is actually one of the advantages with this active-active setup. Another alternative you may want to say, oh, some of the people was, oh, how about setting up the other way, which is, or just mirroring it this way into one aggregated cluster, and then we'll build this pipeline, right, to build the other aggregate cluster. This is possible, but then you have the same problem with the active-passive one, which is if this one goes down, right, there's a lot of reconfiguration you have to do to reverse the mirroring, which is not convenient. You don't have this problem in the other setup. Another way is I think some places, yeah, I think setting up an aggregate cluster is definitely a little bit annoying. So a lot of reasons why we set it up is just to avoid cycles. So this is another way you can do to avoid cycles, which is you can, if you sort of tag the topics differently, right, in both 2 clusters, you can also avoid cycles. It just means when you mirror the data, you will only mirror the topics that's on the remote cluster. And so the two mirror thing can happen in both directions, but they will be mirroring two different disjoint set of topics. Now, the impact with this now, the consumer is a little bit, has a little bit more work to do. Is when you do the consuming, you have to consume potentially topics with different tags, right? Which is a little bit unintuitive because logically they belong to the same data. Now, because of this deployment, you have to do things a little bit differently. But that's another possibility you can do. Okay. Often there's a need to go beyond 2 data centers. Why is that? Because typically the more data centers you have, the better you can utilize the resources. If you have only 2 data centers, you definitely have to budget for 100% of traffic in each data center, right? Because if you lose one, you have to make sure the other one can handle the total traffic, which means you have to budget 200% of the resources. You have 3 data centers, you know, if you lose data center, if you split the load evenly, each data center only need to take 50% of your total traffic, right? So times 3, that means you only need 150% of the budget to handle your peak traffic. So it's more efficient. Now, as you can see, as you have more data centers, right, setting up the pipeline from the local to the aggregate cluster can be daunting because it's like an n-squared pipeline you have to build up. So one of the things you can do to alleviate this problem is when you set up this aggregate cluster, you don't necessarily have to set it on every data center. Typically, it's enough just to pick 2 or 3 data centers to be the aggregator, and the rest of that, you can only have the local one. That will alleviate the number of pipes you have to set. Okay, so we covered this active-active setup. This is just sort of a slide, just shows you the comparison among all the strategies. And we talk about stretched, active-passive, and active-active. With stretched, I think it's easy for the consumers, and you also has a pretty good utilization of resources. You still need some other solution for dealing the cross-region stuff. Active-passive, sometimes you definitely just need that just because if you want to guarantee some of the global ordering, for example, all the data are produced from a database, you want to make sure they are sent into Kafka in that ordering, then you have no choice but to do that in one data center. But you have other problems dealing with the reconfiguration, dealing with the consumer state, and you also have to worry about maybe the resources are fully underutilized. So active-active provide a little better than active-passive, but one of the downside is you do need to set up this actual cluster for the aggregation. These are some other things you have to so this is another thing, I think. Okay, so beyond Kafka, I think typically when you use Kafka, right, Kafka is often used with a lot of other data source because you may want to take Kafka's data, do some computation, and put that into a database. So often when you think about a multi-data center strategy, you have to think it holistically, not just the Kafka part, but make sure all those data sources, including Kafka, they use a consistent strategy. So this is just like a quick example. Let's say you have like an example application. You have an application that just keeps reading from Kafka's topic and then computing this like 1-minute counts, right, based on the events. And you want to store that count in a database so you can serve that to the application. And you want that count to be available in both data centers. Now, how do you do this? It sort of depends on what's the multi-data center strategy for the database as well. So, for example, if you have 2 independent databases, in this case, let's say I have a local database here in one data center, I have another one. These are 2 independent, right? If you want accounts to be available in both places, you have to sort of redundantly consume the data from both data centers. So you read your pipe here, build an account, publish in here, it will do exactly the same thing to populate the other database. This actually has a side effect, which is it actually makes the flip over easier because you are running the consumer concurrently in parallel in both data centers anyway, so there's no manual flip over that's needed. On the other hand, if you have a stretched database, in this case, let's say the database is stretched across data centers. If you write a database, write an entry here, it automatically being propagated over here by the database, then of course, doing the previous one will mean that you now have double writes, right, which is may not something that you want. So in this case, you would have to enable the consumer on one side and only in the failover case, do it in the other one. So this is another point, which is when you think about multi-data center strategy, you want to make sure you think about this holistically. Okay, so there's some other considerations when you set up this mirroring pipeline. One of the things you may want to think through is to enable the security feature in Mirror Maker. One of the things we supported in security is SSL. If you set this up in Mirror Maker, it can encrypt all the data transfer across the mirroring, which can be useful especially if the data centers are far away from each other, that you have to go through a public network. The second thing is some of the performance tuning. Typically, it's common to run multiple instances of Mirror Maker, just as you are a consumer, for better performance. And if the data centers are far away from each other, tuning some of the sockets can amortize some of the long network latency. Another thing is, is where would you run the Mirror Maker? Typically, we prefer to run the Mirror Maker instance close to the target cluster, so that the impact with network will only cause delays instead of data loss. Okay, this is some future work, which I briefly mentioned. So we are working on some of the broker-side indexing based on timestamp. With this, we can improve the performance a lot better for switching over the consumers, because we can get the timestamp to offset translation a lot easier. One of the things we introduced in 2009 is a framework called Kafka Connect. This is actually a framework for doing data ingestion into Kafka. So by making it easy to get data from, for example, databases, logs, other metrics into Kafka. So over time, we expect a lot of the data ingestion will be done through Connect, and we do want to make sure it integrates with the multi-data center story. And yeah, we briefly mentioned the offset preserving feature as well. Okay, with this, I'll just leave you with this last slide. We have a partner at SyncSoft at this conference. If you want to talk more about Kafka or see some live demo, you can come to our booth. If you want to learn more about Kafka through some of the trainings, we do offer some developer training and operational training. You can log onto our website to register yourself. And if you just want to know more about Kafka and then what offerings we have from Confluent, you can just visit our website, and there should be some links that tell you where to go. With that, thanks for coming. I'd be happy to take some questions. Yes? Yes?
The main reason why offsets are not preserving was an assumption that there could be different policies for the same topic from partitioning perspective.
Right.
But in my opinion, it's maybe a false assumption. What's the real use case behind this assumption?
Right. The question is, one of the assumptions we make, which is make offset preserving harder, is the number of partitions are different. So yeah, I think you can make this consistent. You just, every time if you want to change it, right, it's going to be hard to change it at the same time. But I think the main concern with implementing the offset preserving feature is really dealing with the transient failure when you do the retry, when you do the rewrite. Because you just, today, when you have a transient error, right, during the publishing, it doesn't necessarily mean the send fails. It just means it may fail. If you retry, then you need to be able to deal with duplicates. So that's probably the harder part. Yes?
Is the Mirror Maker fault tolerant? And what's the best practice to monitor the Mirror Maker?
Yeah, so the question is the Mirror Maker fault tolerant, what's the best way to monitor it? Mirror Maker supports fault tolerant in the same way as the consumers. If you're familiar with our consumer, we have this concept called consumer group, and the group members are all sort of capped by the brokers. If one instance goes down, the broker will recognize this, and then the coordinator will shift some of the load off this failed instance to others. So there's an automatic failover for you. And Mirror Maker pretty much just embeds a consumer, and it can do the failover in pretty much the same way as a regular consumer works. So if you run multiple instances of Mirror Maker, if one instance goes down, the other instance should be able to automatically take over the consumption. The coordination used to be done through Zookeeper, but since 2010, there's a new consumer library, and it will be coordinated through brokers. So one of the brokers will be designated as the coordinator for this consumer group. And it's it's going to be keeping track of the membership in the group. Yes?
Are there any issues with mirror maker from like a secure to a non-secure cluster, like HDFS to basically say to ignore like Kerberos integration, like going from a Kerberos to a non-Kerberos cluster? Is there?
Yeah, so the question is, are there any security concerns with mirror maker? So if you look at a mirror maker, right, it pretty much just embeds a consumer, which reads from the source cluster, and a producer, which publishes to a target. So both the consumer client and the producer client, they are integrated with security and access control. So when you set up mirroring, you need to make sure that the consumer should be able to read from the source, and the producer should be able to publish to the target. And depending on whether you enable security on the source cluster or the destination cluster, you may need to have the right permission and the right credential set up in the instances. But once you set this up, you can flow the data around. It doesn't necessarily mean you have to have the same permission or access control on both the source and the target clusters if they are in different data centers. Okay. Any other questions? Yes?
So one of your points was the mirror maker should be closer to the target cluster. If you can explain that a little more.
Right, so I sort of only glanced over that. So when you run mirror maker, right, mirror maker can run either close to the source cluster, can also run to the target cluster. I think in general, we prefer to run that close to the target. The reason is, if the data centers are far away from each other, right, you may have like a network outage between the two data centers. So if mirror maker runs closer to the target, what's getting impact is the consumption part. So in this case, you haven't really lost any data, right? You just stop consumption. But once the network is back, you can resume the consumption, and you can continue mirroring data. But if you do the reverse, right, then if you run mirror maker closer to the source, then when there's a similar network issue, what's getting affected is the producing side. So if the producer can't produce, what it will do is just keep retrying. But once you exhausted all the retries, it has no choice but to drop it. So in this case, you actually had data loss. So that's sort of the difference. You can run it either way. You just have to be aware of the configuration.
One more question.
Yes?
Is there a thumb rule or a guideline of the hardware on which mirror maker is supposed to run? Does it have to be similar to the broker hardware?
Right. The question is, what kind of machine would you use to run mirror maker? That, I think, one of the things with mirror maker is in general, it doesn't need like persistent storage. So unlike broker, which needs a lot of persistent storage, the mirror maker is just like your regular client. So it doesn't need a storage. It does need some memory to buffer the data, and it needs a little bit CPU depending on whether your data is compressed or not. So you just need to configure this as a regular application, give it enough memory and CPU. Okay. All right. Yeah, I'll be sticking around. I think if you have any more questions, we can address that. But thanks for coming.